Hello, my name is Andrew Zulu. Welcome to this presentation on Introduction to Vectors. Let's get started. We will consider the following: vector definitions and representation, types of vectors, elementary vector operations, addition, elementary vector operations, subtraction, vector components, 3D vectors and direction cosines, and then we'll also look at the right-handed coordinate system. So before we look at a vector, let's define a scalar. A scalar is a quantity with only magnitude, for example, a mass. A vector is a quantity with magnitude and direction, for example, a force. These belong to a general category of quantities called tensors, for which a scalar is a 0th order tensor, a vector is a 1st order tensor, a matrix is a 2nd order tensor, and so on. Now we have this vector AB, which is this AB, represented as such, AB with an arrow on top, or you can represent it with a half arrow, or you can represent it in bold if it is typed. But the unit vectors, which are the vectors in the XYZ, are represented with a cap, like so, I, J, K. Now, there are various types of vectors that we're going to consider in this segment. We have a free vector, a sliding vector, and a fixed vector. Let's begin with a free vector. A free vector is a vector really for which the action is not confined to a unique line in space. For example, a moment vector. In this rigid body here, the moment vector, you can place it anywhere. You can place it there or there. As a matter of fact, anywhere on this rigid body, it will have the same effect on the rigid body. Then we have a sliding vector. Sliding vector has a unique line in space, but no unique point of application. For example, a force on a rigid body. As long as this force is on this line of application, it will have the same effect on the rigid body. A fixed vector is the rare one. It's got a unique point of application, for example, a force on a rigid body. Now let's look at some elementary vector operations. We'll begin with addition. We're going to consider what is called the parallelogram rule, the triangle rule, and the polygon rule. Now, if you have two vectors, u and v, you add them to get w. We have the following. This is vector u, and this is vector v. You can take the tail of vector u, add it to the tail of vector v, and then you get this, vector w as such. Or you can take the tail of vector u and add it to the head of vector v, and you get this representation. This representation here is a triangle rule, and this one here is the parallelogram rule. And then of course here on the triangle rule, if you have more than two vectors, then of course you're going to get what is called the polygon rule. For subtraction, it works in reverse. So we take two vectors, u and v, u minus v. So what we simply do is to reverse the previous vector that we saw. Now it becomes minus v. So this u plus this minus v in the parallelogram rule that you see here gives us the vector w. Or you can take the head of vector u and add to the tail of minus v, and you get the triangle rule that you see here. So subtraction works in reverse. Then what is called the null vector is simply a zero vector. So you have two vectors that are equal and opposite direction. They form what is called a null vector. An example is here, the vector u here and the vector v. When added, they will give us 0. Now, vectors can also have components in two dimensions. So we have what is called the orthogonal components or the rectangular components. And then we have also what is called the acute and obtuse components. Let's look at the diagram. So the rectangular components are here. So the vector is this A with its rectangular components C and B. And then the same vector A with acute components where this angle here is less than 90 degrees. Of course, this angle was 90 degrees. But if it is less than 90 degrees, you can see that the vector becomes smaller and smaller. And then if this angle is more than 90 degrees, you've got these obtuse components, and the vector components become large. In 3D, we just talk about the vector components in the rectangular vector components. So they are. So let's look at the diagram. So the vector force F will be written as Fxi plus Fyj plus Fzk, where Fx, Fy, and Fz are scalars. Ijk unit vectors in the direction x, y, and z. Then F, to get the magnitude of F, what you simply do is to Pythagoras the Fx, the Fy, and Fz. Okay, and then if you look at this vector representation here, you have F, and then you have Fx. So obviously F cos theta x, this is the angle between Fx and F. F cos theta x gives us this Fx, and then F cos theta y gives us Fy, and F cos theta z gives us Fz. So this cos theta x, which is obviously Fx divided by F, is called the direction cosine in the x direction. Can also be represented by the letter L. And similarly, cos theta y will be Fy over F, which is represented by M. And then the direction cosine in the z is cos theta z, which is Fz over F, represented by M. Then obviously cos theta x squared plus cos theta y squared plus cos theta z squared, when you add them, you should be able to get 1, and that's what you see right here. So that's the representation of these vectors in 3 dimensions. Looks like a concept that we're going to be using quite often in the analysis of 3D vectors, and that is the right-handed coordinate system. It works out as positive counterclockwise. So how does it work? So we have these fingers here. We've got the thumb and 2 fingers, okay, that show us the direction of these vectors. Okay, I hope you're going to twist these fingers in this direction. Otherwise, don't try this at home, you could get hurt. But anyhow, this is X in black. If this is X in black, then this one is Y and this one is Z. So it works counterclockwise, cyclic counterclockwise. And then in blue, if this is X, then this is our Y, and then this is our Z. And then in red, if this is X, then this is our Y, and this is our Z. In this video, you have learned about what vectors are, types of vectors, which are free, sliding, and fixed vectors. You have learned about elementary vector operations of addition and subtraction. You have learned about vector components in 2D, which were obtuse and acute and orthogonal, which we call the rectangle components. You have also learned about vector components in 3D, and you have also learned about direction cosines, and also you have read about the right-handed coordinate system. That's all for this segment. Thank you for your kind attention.